Today, we're going to cover Chapter 1, Lesson 6 Extension, which is adding and subtracting fractions. First, open up your journal to the next available page, title it Least Common Denominator, or LCD, and copy down the following definition. So in your journal, write least common denominator and then in parentheses LCD, and the least common denominator is the least common multiple, or the LCM, of the two denominators. So those two numbers, we're finding the least common multiple between those two. If you're waiting to move on, go ahead and update your table of contents in your notebook. Now under this definition, we're also going to write a few steps on how to add and subtract numbers or fractions with different denominators. So these are also going to be written in your journal. Write them right underneath the definition you just wrote down. So number 1 would be find a common denominator using the LCM of the denominators. So we're going to find the least common multiple of the two denominators we start with using that process there. If we struggle with that, go back to your notes on LCM. That's a good place to look for that. The second step would be to rewrite the original fractions with the least common denominator, that LCD, which is the least common multiple of the two denominators. Our third step will be adding the numerators, and we keep our denominator the same. That LCD will stay the same. And then our last and final step, we always simplify our fractions if we can. Now sometimes they'll already be simplified, but if we can simplify it, make sure we remember to do that. So go ahead and pause this video until all the students have copied that down. Now before we add and subtract fractions with unlike denominators, we're going to compare fractions with different denominators. So this is a method you guys may be familiar with. It's called the shoelace method. We take our top numerator from one of our fractions, and we multiply it by the number diagonal from that, the denominator of our other fraction. So 1 times 3 would be 3. We do the same process except the opposite way around. The numerator of my second fraction times the denominator of my first fraction. 1 times 6 is 6. Now I'm looking at these two numbers, 3 and 6. Whichever number is greater, that's the way we write our greater than sign. So 3 is less than 6, or we could say 6 is greater than 3. Now see, we call it the shoelace method because when we crisscross these lines, it kind of looks like your shoelace. So if you have a tennis shoe on, go ahead and look at your shoelaces. Hopefully they're laced up like this. You might have a fancy shoelace, but this is how normal shoelaces look. So this would be the same for any two fractions when we're comparing. If these two numbers at the end are the same number, we would have an equal sign in between those two. And if the first number is greater than the second number, our symbol here would be flipped around. So if we had something like 1/3 and 1/5, we'd use our shoelace method. 1 times 5 is 5. 1 times 3 is 3. So 5 is greater than 3. Now, you might see fractions that don't have 1 in the denominator, but this is the proper way to compare. There's a couple other ways we can do, but this is one of the simpler methods, so we're going to start with this one. And now we're going to move on to adding and subtracting fractions with unlike denominators.
When we're adding two fractions with unlike denominators, we're going to follow the steps we wrote in our notebook earlier today. Our first step is to find the least common multiple of the two denominators, so we can find a common denominator. In fact, this will help us find the least common denominator. Like we wrote down before, our least common denominator is the least common multiple of the two denominators we have. We have a couple of methods for finding the least common multiple of two numbers. We're going to use list of multiples for this example. When I list my multiples of 8 and I list my multiples of 6, I will find a lot of common multiples, but I want to find my least common multiple. So here we've circled 24 and 24. Here we've circled 48 and 48. We could go on down to infinity and find a bunch of them that we have in common, but we want to use 24 as our least common multiple. Here we go. The book told us the least common multiple of 8 and 6 and 24. So the least common denominator for these two fractions is going to be 24. Our next step tells us to rewrite the fractions using the least common denominator or using the least common multiple of the two denominators. So we're going to rewrite our fractions with a denominator of 24. I'm going to show you off to the side before the book shows you. I want to get two fractions with a denominator of 24 using my original fractions. When I took 5/8 and made it into this original fraction, or this fraction with my new common denominator, I had to do something to this denominator, 8, in order to get my new denominator, 24. When we ask ourselves, what do we do to 8 to get to 24? We can look at our list of multiples if we even want to. We're multiplying by 3. If I multiply by 3 in the denominator, I'm also going to multiply by 3 in the numerator. Whatever I do to the bottom of my fraction, I have to do to the top of my fraction. I multiplied by 3 in my denominator to get 24, so I'm going to multiply by 3 in my numerator to get 15. Here's my new numerator. The same logic works for my second fraction. I multiplied by 4 to get to 24, so I'm going to multiply by 4 in the numerator to get to 24, to get 4 over 24. Here's what our book says. The exact same thing I just said. The bottom we multiplied by 3, so the top we're multiplying by 3. The bottom we multiplied by 4, so the top we're multiplying by 4. We're going to rewrite our fractions using the least common multiple. 15 over 24 and 4 over 24. Look, we were right. Our next step is not to multiply because that's not what our step is. It tells us to add. Our step right here is to add, so we're going to add the two numbers. In fact, like we wrote down earlier, we're going to add the numerators and keep the denominators the exact same as we had them before. When I add 15 and 4, I get 19. And I'm going to keep my least common denominator because I worked so hard to get it. My last step, always, 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 is to simplify, but we can't do anything to simplify 19 and 24, so I'm going to put a box around my answer. 19/24 is my answer. Does it show you guys the time?
You did good.
I didn't stop recording. It's still recording. Stop recording! And we're back. The next problem is going to be subtracting, and we're also using mixed numbers. So we have to sort of add in a first step here, where we're changing our mixed numbers into improper fractions. Then we can do all the stuff we just did again, because now we're very good at it. My first step for making a mixed number an improper fraction is to use the big C method. We're going to start with the denominator of our fraction, and we're going to wrap around to the top. Here we're multiplying, here we're adding. 4 times 4 is 16. 16 plus 3 is 19. So the new numerator of my mixed number, that's now an improper fraction, is going to be 19. My denominator stays what it was before. I'm going to do the same big C method with my other mixed number. 10 times 2 is 20. 20 plus 3 is 23. So 23 is my new numerator. My denominator is going to stay what it was before. It's going to be 10. Now I can go through all of my same steps for subtracting numbers with different denominators. My first step, like it was before, so my first fraction is now 19 over 4, and my second fraction is now 23 over 10. It's going to tell us to find the difference, which means we're subtracting like we thought before. Our first step, like last time, is to find a common denominator, and we're going to use the least common multiple of our two denominators, which is 4 and 10, in order to find our least common denominator. Since the least common multiple of 4 and 10 is 20, we're going to rewrite our fractions using our least common denominator, which is 20. So we're going to rewrite both fractions with 20 as our denominator. Just like last time, we figure out what we do to 4 to get to 20, and we're multiplying by 5. So we're also going to multiply by 5 on the top. We're going to have 95 over 20 as our first fraction. Our second fraction, we multiplied by 2 on the bottom. So we're also going to multiply by 2 on the top, so everything's fair and copacetic. We're going to have 46 over 20. Now we can do the actual subtraction part. When we take the difference of 95 and 46, we're going to get 49 over 20. We subtract the tops and we keep our common denominator as our common denominator. We work so hard, we're going to keep it. I'm not finished because my problem isn't simplified. I have to make this back into a mixed number because it's currently an improper fraction. I'm going to figure out how many full sets of 20 I have in 49. I have 2 full sets of 20 in 49, so I'm taking the 20s out of the 49, and I have 9 pieces left. My final answer is going to be 2 and 9 over 20.
Your homework for tonight is actually page 27 and 28, so front and back, from your Record and Practice Journal, that green Record and Practice Journal. It'll say extension 1.6, practice at the top. You can rip that out. Start working on it in class now. If you're still struggling a little bit, make sure you're looking at your notes as you're going through this. And if you want a few more examples to look at, pages 42 and 43 are great resources out of the textbook. So you can use that textbook underneath your desk, look through, look at the examples, and see if those will help you out while you're doing your homework tonight. So that will be the only thing. We'll check that on Monday. That will be due on Monday for you. Make sure you're working hard the entire rest of the hour, and we will see you Monday.